An infant, stillborn, with a single eye in the middle of its forehead. An echo of the monstrous Cyclops, it is the result of a mutation in just one of our 30,000 genes. Mutations are personal tragedies, but they are also a way of finding out how our bodies are made. This series is about the extremes of deformity and the limits of humanity. It's about how deformity reveals the devices that go into making a normal human being. It's about mutants. And we are all mutants, but some of us are more mutant than others. This film is about the making of the human form, the origin of order in the womb. It's about why we have one head, not two, two eyes, not one, and our organs in all the right places. It's about how mutants reveal the devices that make us all, how exceptions illuminate the rule. Our story begins here in Paris in 1829. And it begins with the deaths of two small girls. No sooner had they breathed their last than a band of anatomists came to seize their corpses. For the anatomists who took them, they were marvels of nature, enigmas. They brought the remains here to the Muséum d'Histoire Naturelle, and then they cut them up. Except they didn't cut up two corpses, they cut up one. Rita and Christina Parodi were the daughters of Sardinian peasants. Obscure in life, they were famous in death, and France's scientific elite turned out for the show. The girls were beautiful, and they were strange. Individually profoundly deformed, together they were symmetrical, proportionate, and utterly conjoined. One of the anatomists who attended the dissection was Etienne Geoffroy Saint-Hilaire. In 1829, Etienne Geoffroy Saint-Hilaire was professor of comparative anatomy here at the Paris Museum. One of the most mercurial intellects of his time, everything he wrote has a touch of genius and of the absurd. It is in his hands that teratology, literally the study of monsters, first becomes a science. And Geoffroy, he becomes the presiding genius of deformity. Geoffroy was entranced by Rita and Christina. To him they spoke of unknown forces in the womb. But had those forces split two girls out of one, or forged one girl from two? All that remains of Rita and Christina can be found here at the Gallery of Comparative Anatomy. Looking at this plaster cast of the girls, it is easy to see why they fascinated Geoffroy. Distinct from the shoulders up, their torsos gradually melt into each other. They died when they were only 8 months old,
And yet, even though they were so young, they seemed to have different personalities.
We ordered up one more bottle of wine. You told me your story and I thought about mine. You said when you lost her, you lost everything. It all started having a familiar ring. We ordered up one more bottle of wine. You told me your story and I thought about mine.
Laurie and Reba Chappelle are 42 years old. They are the only adults in America to be joined at the head.
Reckless hearts can clear a path wider than a hurricane's aftermath. We both traveled down that road where in the name of love anything goes.
My name is Laurie Chappelle, and I live in a little town called Reading, Pennsylvania.
Hi, I'm Reba. Live the same place she does. I'm in show business. I'm a singer and actor.
We share bone, tissue, and blood lines, and that's about it. We're conjoined just right at the corner of each of our left eyes. We each have an eye. If you were to separate us, we'd each have a full functioning body.
Laurie and Reba share brain tissue, but despite the intimacy of the connection, each has a powerful sense of her own individual identity. Their concerns, they say, are the same as anyone's, and just as humdrum.
You know, I don't wake up saying, oh my goodness, I'm a conjoined twin. I don't go to bed with the last thing on my mind, I'm a conjoined twin. I go to bed wondering if I turned off the stove or if I didn't leave the house with something running that shouldn't be. You know, I'm just a normal person with a little connection to my sister.
Conjoined twins are often called Siamese twins. The reason for this can be found in a Philadelphia museum not too far from Laurie and Reba's hometown. This is a cast of Chang and Eng Bunker who sailed from Siam, arrived in America in 1829 and found fame. Their livers, preserved here, were joined. When one drank, they both got hangovers. A few of their hairs remained stuck to the plaster. When the original Siamese twins, Eng and Chang, first toured the United States, they advertised themselves with the slogan, E pluribus unum, out of many one, that you can see on any US dollar bill.
Chang and Eng proclaimed their oneness even though they were only joined at the liver. 2 out of 1 or 1 out of 2. For most of recorded history, the question has been beside the point. Instead, Siamese twins were seen as having political or religious significance.
The book that I have in front of me is a marvelous work. It is called L'Histoire prodigieuse, The History of Prodigies. And it was written in 1560 by Pierre Boaistuau, a French Protestant scholar. It's not just any work, however. It's an illuminated manuscript, and one that was given to Queen Elizabeth I of England. And it's gloriously illustrated. It is an account of the monsters and marvels of Boaistuau's day. In here you can find pictures and stories of hairy gulls. You can find kings who are having liposuction by leeches. Satanic monsters such as the monster of Krakow who has barking dogs' heads on all his appendages. And above all, you can find conjoined twins.
In books like this, deformity is rich in allegorical meaning, revealing God's views on current events. Conjoined twins tend to signify either political union or an outbreak of peace between warring states.
One of the most beautiful images in this book is this. Boaistuau says they look like a tree, one with a single trunk from which two branches emerge. But for me, they look like a pair of Botticelli Venuses who have somehow become entangled in each other. Geoffroy, writing 250 years after the history of prodigies, saw conjoined twins as a natural phenomenon that required a natural explanation.
For Geoffroy, Rita and Christina were not an arbitrary quirk of fate, and they certainly weren't a divine creative flourish. They were instead the products of natural laws, laws that made their body, laws that made all bodies. What is more, Rita and Christina, read rightly, could reveal those laws. What I have here is a bucket of human guts. It's somebody's insides that have been scooped out and preserved in formaldehyde. And the whole thing is really rather rank. Over here we have the lungs, over here's the heart. It's pretty fatty. We've got a liver over here, stomach, spleen. Down here must be the internal genitalia. There they are, you can see them. Uterus, 1, 2, ovaries. She's a she.
These viscera tell us something important about conjoined twins, but they also tell us something important about all of us. They do so because they belong to a mutant.
So what makes her so special? Well, it's the orientation of her organs. You can see it with the heart. Over here we've got the heart, and if you take a look, you can see that the apex is pointed down towards the right. Mine is down here on the left. And take a look over here at the spleen. Her spleen is on the right. Mine's over here, it's on the left. And then if we take a look at her stomach is on the right. Mine is on the left. One of us must be wrong. And it's not me.
The disorder is called situs inversus. It's characterized by left-to-right reversal of the internal organs. It's rather rare, except in conjoined twins. Christina Parodi's organs were the right way around, but not Rita's. She had situs inversus. Her heart was on the right-hand side of her body. This intrigued Geoffroy. It suggested to him that conjoined twins had something deep to say about our geometries. But Geoffroy didn't just want to find deformity, he wanted to make it. As a young man, he had conducted crude experiments on chickens, trying to create monstrous birds in the hope that they would reveal the origins of order in the embryo. The results, however, were not as illuminating as Geoffroy had hoped. When his chickens hatched out, they proved to be more dead than deformed. If Geoffroy's technique was crude, his idea was not. It is in essence the same one that guides the work of modern geneticists. Like Geoffroy, they manufacture deformity in order to reveal the laws of normal development. We start life as a fertilized egg which divides and then becomes a cluster of cells. But how does this simple sphere turn into the complex structure which is the human body? Just 13 days after conception, an extraordinary transformation occurs. The embryo begins to organize itself. This process is called gastrulation. Gastrulation gives the embryo its geometry. 2 weeks after egg meets sperm, an embryo has a head and a tail, a front and a back, and a left and a right. The question is, how did it get them?
To put it another way, do the embryo cells just know what to turn into, or is each one told?
The answer came in 1923, when a young woman began working for Hans Spemann, a German embryologist. Hilde Prochelt reasoned that if something was instructing cells how to organize, perhaps it could be transplanted from one embryo to another. It was to become the most important experiment in all developmental biology.
This was a very difficult experiment to do, particularly the first time that one does it. Now we can repeat it in the lab, but at that time was a great tour de force.
Professor Edward de Robertis is a leading developmental biologist. He's recreating Hilde Prochelt's experiment using toad embryos.
First, we must remove a membrane that surrounds the egg. We remove that with tweezers. We then turn the embryo upside down. We can then excise this tissue, and it can be used to graft onto the opposite side of a host embryo.
Prochelt's experiments were a subtle and precise version of what Geoffroy was attempting with his chickens.
Would the transplanted cells behave differently from the hosts?
The host embryo has remarkable properties of healing. And so the cells essentially invade the new embryo and they form part of it. And within half an hour, they are already integrated perfectly well.
Prochelt carried out over 250 transplantations. Almost all of her embryos died. But transplanting one particular piece of tissue had an extraordinary effect. The transplanted cells organized the host cells into an extra but conjoint creature.
I've read about these kinds of tadpole spheres from when I was a student. I've written about them too, but I've never actually seen them. And actually it's a rather moving thing to see them for the first time. Over here's one head, over here's another, and they're twitching like mad. They're alive, as you can see. I mean, this is one of the greatest experiments in 20th century biology. And here it is, reproduced completely, and in living color, living twitching color too.
The experiment told us that individual cells do not govern their own fates, but are organized somehow by instructions held within the tiny patch of tissue.
When they found the conjoined twin, they realized that the cells that they had grafted told the neighboring cells to form new fates, such as, for example, induce a completely new brain. So this had like a magical power that was called the organizer.
The organizer suggests an explanation for Rita and Christina. Perhaps they were also the products of two distinct organizers located on a single embryo.
The geometry here is almost exactly the same as that which you see in Rita Christina Parodi, for example. They've got two heads and a single axis, exactly as Rita Christina had. Two parts just completely joined together. It's an astonishing thing, actually.
Prochelt's experiment started the hunt for the source of the organizer's power. To produce form out of nothing, to transform a simple clump of cells into something with shape and order. The search was to take nearly 70 years. The organizer limited the potential of the cells around it. It told some cells to become front, others back, some the head, some the tail. It was the origin of order itself. The organizer is simply a clump of cells at the edge of a deep ravine in the developing embryo. As other cells flow over it, they are assigned their different fates. Some cells form the head, others the tail. Some become nerve cord, others skin. It's a complex and subtly constructed piece of biological machinery, and to understand its power, biologists turned once again to mutants. Away from the canals and bridges of tourist Amsterdam is a macabre assemblage of deformity and disfigurement. It can be found at the city's Vrolijk Museum, one of the world's great collections of human mutants.
The Vrolijk Museum is a house of horrors. A vision of hell, but one that is cleansed of moral value. One based entirely upon scientific values, in which horrors are presented for the sake of understanding.
Teratology, the science of monsters, was fashionable in the 19th century. But then obscurity claimed it. No longer. These days, museums such as the Vrolijk have gained new value as molecular biologists examine the rows upon rows of babies in bottles. Most of the specimens in the Vrolijk Museum are mutants, the result of errors in one of the 30,000 or so genes contained within the human genome. Genes that are needed to give our bodies order, that are needed for life itself.
I can't deny there's a pleasure if a guilty one, in the macabre, and seeing things which one just hardly imagined could have possibly existed. Until you have walked around a collection such as the Fröhlichs, it's difficult to appreciate the possibilities of the human body. One of those possibilities reveals important information about the complex workings of the organizer. Like the Cyclops, it echoes a mythical creature, a mermaid.
Serena Amelia, or mermaid syndrome, is one of those disorders that crops up all the time in the great teratological collections of the 19th century. The condition is named for the sirens of Greek myth, and it's easy to see why. Just like a mermaid or a siren, these infants have legs that are fused together in a single tapering trunk from which the feet protrude like little flippers.
I started swimming at a young age, about 2, because I've been in the water so much. I've kind of taught myself how to swim, really. Just getting used to the water and not being afraid of it.
Tiffany Yorks is 16 and lives in Florida. She was born a mermaid.
I was born with Sirenia, which is also known as mermaid syndrome. It's when a baby's born with their legs fused together from the hips down to the ankles. A lot of people don't believe me. They think it's something I made up because it kind of does sound like something somebody would make up.
Sirenia is usually fatal because it affects many organs, among them the heart. It's what's known as a midline disorder. The lower half of the body collapses in on itself, creating a single leg.
The first time I looked at Tiffany when she was in an ICU in an outlying hospital, I said, yes, by golly, it is a mermaid. And our first step was for me as a plastic surgeon, how are we going to separate the legs when there's not enough skin?
The operations on Tiffany took plastic surgery to a new level. The lower half of her body had to be entirely rebuilt.
Everything was based on innovation and improvising what is known in the principles of plastic surgery in order to perform an operation to make a patient survive.
My left leg kind of points out, the ankle points out. It is a little bit weird looking, but they're my legs and, they don't bother me. When I first walked, I don't really remember much of it, but I remember it being a very happy time because when I was little, all I wanted to do was walk. I wanted to be able to walk like everyone else, and when I finally did, I was very happy.
The fused leg is a reflection of other problems in the body. It's like a cascade. They all work together. It's an orchestra. When one organ doesn't work well, the other organs may not work well.
Tiffany is unique. She's the only person in the world with this catastrophic disorder to live to the age of 16.
I would tell parents it's okay and that their child does have a chance to survive this because I've survived this and I believe that they can too. It's a very difficult situation, but if you think positive and go on like that, then you can do it.
Until very recently, the causes of Cyrene-Emilia have been obscure. But molecular genetics has told us something about the disorder's origins. And unsurprisingly, it lies in the organizer. For 70 years after the discovery of the organizer, biologists searched for the source of its power. They knew what they were looking for, a substance secreted by the cells of the organizer that filtered into the embryo and told other cells what to do. The substance itself, however, proved elusive until the advent of molecular biology.
The organizer experiment was almost forgotten. In the early 90s, molecular biology underwent such great advances that it was possible to make gene libraries from very small fragments of tissue. And this was the key advance.
The organizer had been discovered by transplanting bits of tissue. But the tissue was made up of many cells, and each cell contains many molecules.
De Rubertus isolated genes from the organizer tissue and then inserted them into an embryo. The breakthrough finally came in 1994.
When I saw the twinned embryo, I jumped on top of the bench. It was an amazing moment.
One of de Rubertus' genes expressed a molecule capable of inducing conjoined twins. He called his discovery cordon. It was a signaling molecule. And as it turned out, it was the first of many. When the cells of the embryo sweep over the organizer, they are given a set of instructions telling them what to do, where to go, and what to become. Instructions conveyed by one or more of 7 signaling molecules.
In a way, the embryo is just a microcosm of the world we inhabit, a world of signals, which insistently urge us to travel to one destination rather than another, hold some things to be true and others false, issue some goals in favor of others. In short, that molds us into what we are. Tiffany York's disorder seems to have been the consequence of a breakdown in signaling between the organizer and the cells that would become her legs. The signaling molecule responsible is called retinoic acid. Retinoic acid is powerful stuff. A lovely experiment illustrates this. If one chops the tail off a tadpole, it normally regenerates. If, however, one dips the stump in retinoic acid, you don't get a tail, but rather a messy cluster of legs.
Retinoic acid seems to direct cells to form limbs and other lower organs. Too much retinoic acid, and the body starts to manufacture extra parts.
This is John Shifford, or at least a wax model of him below the waist. A 20-year-old native of Lancashire, he had, in case you missed it, 3 legs and 2 penises. He claimed, impressively, that they were both fully functional.
A surplus of retinoic acid may have been responsible for doubling John Shifford's firepower and endowing him with an extra leg. The human equivalent of the retinoic tadpole. Mutations that can disrupt the concentration of retinoic acid can also cause sirenomelia, which is probably why Tiffany was born with 1 leg instead of 2.
I do feel special in a way because I was given such a miracle to survive, and I believe God had a purpose for me to put me here, and I'm gonna keep going on and figure out what that purpose was.
The organizer is, however, only the first and greatest of many organizing centers that collectively give the body its form. Each of the embryo's parts are shaped by their own sets of signaling molecules. Here in San Francisco, researchers are studying the formation of one of the last parts of our bodies to form, the face. They are trying to find out how the architecture of our eyes, noses, lips, chins, and cheeks fit together.
This is the head of a pig, a Duroc pig from Iowa. But it's not just any old Midwestern pig. This pig has 2 faces, 2 snouts, 4 nostrils, 3 eyes. They keep it here in a jar in the University of California, San Francisco, and they call the pig Ditto. Pig, pig, Ditto the pig. Get it?
Gosh, well, there he is. There's Ditto.
Yeah.
I mean, how exciting.
Yeah. So here he is as a piglet, and he's a little unsteady on his feet, as you can see. Now, there are a few things that this pig has to contend with that other pigs don't. You see his third eye there in the center.
So he can actually see through that third eye.
It's not clear, but he does have an optic nerve that connects. Don't know. I don't know. Well, he had a very difficult time suckling, of course, and competing with his brothers and sisters.
Yes, you would have thought they'd been twice as good, huh?
Yeah.
Might have been able to latch onto 2 simultaneously.
I think the third eye confused things, though, because you had to locate it.
Of course. Yeah.
He's gonna topple, but
going.
Over. There you go.
There he goes.
Yeah. But luckily, somebody's there to rescue him and right him.
That's the most pathetic thing you've ever seen, isn't it?
It's very sad. So why are you laughing?
Yeah, I know. It's not appropriate.
But look at
for the
that.
scientific attitude.
Yeah.
But Ditto the pig is not the only oddity that has ended up in Jill Helms's lab.
What I have right here is a chicken that has 2 upper beaks. This is one upper beak, and this is the second upper beak. So it has the equivalent of, in a human, it would be like 2 noses.
Jill Helms has discovered a molecule that controls the shapes of our faces. Named after a video game, Sonic Hedgehog is one of the most ubiquitous signaling molecules in the developing embryo. Like Geoffroy, her experimental animal of choice is the chicken.
The experiment is to take a bead that's soaked in this Sonic Hedgehog protein and place it in a slightly different place in the embryo, still within the face itself, but in a region where Sonic isn't normally expressed, and then see what happened as a consequence of that.
By creating a surplus of Sonic, Jill Helms hopes to disrupt normal facial development. The eggs are sealed over and the embryos left to grow.
I remember peeling back the Scotch tape and looking, and it was quite clear to see the egg tooth, which is the marking on the tip of the beak.
These tiny white specks seemed unremarkable, but they were a revelation. The beginnings of two separate beaks.
And I saw two of them, and I thought it was just a glinting of the light. And it was only when the embryo was dumped out into a dish and we started examining it more carefully, and then the next one came out and it looked the same, and the next one, that we were really quite sure and very surprised and delighted. Then I was left with the feeling of, what does it mean? What does it mean?
Order in the embryo begins with the organizer. But as the power of the organizer wanes, each part of the body comes to produce its own geometry with its own set of signaling molecules. And Sonic Hedgehog controls the width of our faces. Too little Sonic, and the face folds in on itself. The result is a cyclopic infant with a single eye in the middle of its forehead. Too much, and you end up with Ditto, a pig with two faces.
Ditto is an example that shows us what these malformations can be at the most extreme. And I think that they set up for us a sense of a continuum, that we can go from cyclopia to what? To duplications of entire parts of the face.
Ditto was a single pig. But he reminds us of conjoined twins, and they have this in common. Both are the result of surplus amounts of signaling molecules in the embryo, but just at different times and scales. But is a surplus of signaling molecules all it takes to make conjoined twins such as the Parodi sisters? This specimen, the most striking form that conjoined twins can take, suggests a final, deeper force at work.
This is one of the most exciting of conjoined twins. It's a type known as Cephalothoraco-Iliopagus, cephalo head, thoraco thorax, ilio intestine, pagus, the whole lot joined together. They are Janus-faced twins. Two faces looking away from each other. That's weird, but what's really weird is that each face is a composite. Each face is made of half of the face of twin 1 glued to half the face of twin 2. And this tells us something beautiful and important about embryos.
Two organizers working on a single embryo may be a neatly plausible explanation of conjoined twins, of how to get two embryos out of one. But it has nothing to do with their most important feature, the fact that they are glued together. Nor does it explain why the join is always between the same parts of the two bodies, head to head, waist to waist, chest to chest. Conjoinedness enthralled Geoffroy. To explain it, he proposed a law, the law of affinity of like for like. He believed that as embryos form, cells use a sort of biological magnetism to identify and link with their own kind.
Geoffroy hadn't actually seen embryos doing this. He just inferred it must happen this way. And he was, in essence, right. Geoffroy's law, although vague, was the first scientific explanation of connectedness. Recently, we've learnt a lot about this. It's not caused by some vague form of attraction, but rather by cell adhesion molecules, the Velcro of the body. They ensure that the millions of cells in an embryo sort themselves out correctly. Each kind of cell has a unique set of them, which enables it to attach to similar cells and those alone. The problem arises when a twin gets in the way. If that happens, the cells of the two embryos stick to each other and can become hopelessly intertwined. And so to Rita and Christina Parodi, whose body was the resolution of a conflict between the divisive forces of the organizers and the unifying impulses of cell adhesion. Mutations are rather like an anatomist's scalpel. They slice into and reveal the logic of the embryo. They have shown us the signals that instruct cells and the Velcro that binds them together. They show us how only 30,000 genes make us what we are.
Geoffroy Saint-Hilaire normalized monstrosity. He showed that these strange forms could be classified just as previous generations of naturalists had classified animals. He intuited that monsters were not divine jokes, mere arbitrary errors of nature, but that they were the consequences of natural laws, the same kinds of natural laws that gave rise to the diversity of animals that we see around us in this gallery.
And by extension, the laws that make us.
There are no monsters, Geoffroy said. Nature is one. In the way of French aphorisms, this is a little cryptic. But if you come here and look at what is left of Rita and Christina, it's easy to see what he means.
Next week on Human Mutants, Race and Beauty. We look at our heads, our hair, and the color of our skins, and what they mean to us all.
You don't have to wait until next week because that's tomorrow at 10 past midnight. Well, next on 4, De La Soul and Craig David at the Urban Music Festival with the Prince's Trust.